Greetings, chemistry students. The past couple days, we've been talking about ionic compounds, those involving a metal and a nonmetal, and we've been writing chemical formulas and naming these compounds. But today, I'm going to start talking about the second type of compound, which is covalent compounds or covalent bonds. And covalent bonds occur between two or more nonmetals. In other words, we're working with the elements on the right-hand side of the staircase line plus hydrogen. And also, just for some clarity, as far as metal versus nonmetal, we also have the metalloids. But for the purposes of ionic versus covalent compounds, we're just going to say that if it's to the right of the staircase line, we treat it like it's a nonmetal. And if it's to the left, we treat it like it's a metal, just for the sake of whether we're going to name it as a covalent or an ionic compound. And in covalent bonds, they share their valence electrons in their outermost energy level. You may notice that this entire slideshow that we're going through right now is called Chemical Bonding Part 1. In Part 2, we're going to talk a lot more about how this sharing of valence electrons actually works. And when you form a covalent bond and a covalent substance compound, we call that thing a molecule. Although the term molecule is used a lot of times to represent just any chemical compound, it really is specifically reserved for covalent compounds. Now, with covalent compounds, there are some prefixes that we need to know. Those prefixes are as shown here. For one, the prefix meaning 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 is nona, and 10 is deca. So you're going to need to know those prefixes. You'll probably want to write them down, make a note, have them handy and available for you to use. Now, for naming covalent compounds, it's really simple. You write the name of the first element, you add a prefix, you write the name of a second element, you add a prefix, and you change the ending to IDE. So for instance, if we have the compound Cl2F7, since we have two chlorines, we would call that dichlorine, and then 7 fluorines, that's going to be heptafluoride. Because it would be hepta means 7, fluorine, and change the ending to IDE. It's that simple. I do want to remind you of this. Just like with the names of elements, the names of compounds are not considered proper names. We don't capitalize them. It's all done in lowercase. It is, however, 2 words. It's the dichlorine and then the heptafluoride. There is a space in between them. Now, there are a couple of exceptions to this rule, because of course there's exceptions to rules. There's exceptions to every rule in chemistry. So the exceptions. First, never use mono for the first element. If there's only one of the first element, don't use mono. And 2, instead of tetraoxide and pentaoxide, we say tetroxide and pentoxide, and so forth. It's the AO combination is one that is not used very often in English, so we drop the A. So for instance, that would leave us with this compound, CO2. We've got 1 carbon, so we just write carbon. And then we have 2 oxygens, so it's dioxide. It is not monocarbon dioxide, it's just carbon dioxide. And then we have CO is carbon, and then so this is 1 oxygen, it's monoxide. It's another case where instead of calling it monooxide, it's monoxide, carbon monoxide. Carbon dioxide is a product of combustion. You're probably familiar with it. It contributes to global warming. That's carbon dioxide. Carbon monoxide is a byproduct of incomplete combustion, such as charcoal on a charcoal grill, or if you have a gasoline engine that's not tuned properly, or in cigarette smoke. And carbon monoxide is a deadly poison It will bind to your hemoglobin like oxygen does, except it doesn't let go like oxygen does. It essentially reduces the ability of your blood to carry oxygen, and so ultimately it causes you to die. So carbon monoxide, extreme poison. But that's how you name covalent compounds. And to write a covalent formula, you just write the symbols and get the subscripts from the prefixes. So if I asked you to write the formula for dinitrogen tetroxide, it's just N, and there's two of them, so it's N2, then O, and tetra means 4. For covalent compounds, we don't worry about charges. Charges don't matter. All we worry about is the prefixes. Now, the thing is, you cannot use these rules with ionic compounds. Do not start calling CaCl2 calcium dichloride. That's wrong. It's just calcium chloride. And we don't need to call it dichloride. That would be redundant. There's only one way to make calcium chloride. Calcium's a +2 charge, chlorine's -1. It's always CaCl2. We don't call it calcium dichloride because that's an ionic compound. So, a couple of things to help you out here. So, I've got a little flow chart for naming compounds. Just ask yourself, is the first element a metal or the polyatomic ion ammonium? And you remember where your metals are, that's the things on the left-hand side of the periodic table. If it's on the right-hand side of the staircase line, it's a covalent compound, you use your prefixes. If the first element is on the left side, or it's ammonium, which is a polyatomic ion, then obviously this compound is ionic. So then you have to ask, can that first element have multiple charges? In other words, is it one of those transition metals, tin or lead? If so, we need to use Roman numerals in the name of the compound. If not, we don't use prefixes or Roman numerals. So if it can have multiple charges, we use Roman numerals. If it's a covalent compound, we use prefixes. If it's an ionic compound with only a single charge, we don't use either. So if we synthesize all this together, I leave you this lovely chart where if the first element is in yellow, we use prefixes. If the first element is highlighted in blue, we use Roman numerals. And if it's neither of those, we don't use either.